In this video, we'll go over 2 application problems using the distance formula. So find all points having an x-coordinate of 3 whose distance from point -2, -1 is 13. So it tells me in here distance. So my formula for distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, my information in this, it says whose distance from this point is 13. So that one's very clearly my distance, my D. Pick this point here to be either, if I want to call it P1, then this is x1, y1. And then if it wants me to find all points having an x-coordinate of 3, what this means is that I have 3, comma, y. Tells me the x-coordinate is 3, but I need to find that y-coordinate. And so this will then become my x2, y2. Okay, so plug in your information. My distance is 13. X2 is 3 minus x1, which is -2, so it's going to become +2. Y2, I don't know, so we'll call y. Minus y1, which is a -1, so again, another +1. So now we need to simplify. And then solve for y. So here we're still going to have the square root. 3 plus 2 is 5, and 5 squared is 25. Plus y plus 1 quantity squared is y squared plus 2y plus 1. We should be familiar with that, but if you need more, you've got x plus 1 squared. That's the same as x plus 1 times x plus 1. We FOIL. Y times y is y squared. Y times 1 is y. 1 times y is y, and 1 times 1 is 1. Combine your like terms, and you get 2y. Okay, now I can combine my like terms. 25 plus 1 is 26. And I'm going to go ahead and put this in standard form here. So this will be y squared plus 2y plus 26. Okay, so now I need to get rid of the square root. We've done this before. The opposite of square root is to square. So 13 squared is 169. And then square root and square cancel, and I am left with y squared plus 2y plus 26. We now have a quadratic equation, right? Because we have a squared term. So we need to get everything to one side. So let's subtract our 169 over. And we get 0 equals y squared plus 2y minus 143. Okay. I'm just going to bring this up here, rewrite it. And now we need to solve this. Can't use square root method because of this y, but I can use a quadratic formula or factoring. Factoring is going to be easier if it works. So let's see if it works. My a times c is -143 and my b term is 2. What adds up to 2 but multiplies to a 143. I'll give you a minute to think about it. Okay, if you want more time, pause the video. Okay, but this is 13 and negative 11. This is an easy trinomial. So this becomes y plus 13 and y minus 11. So these both equal to 0 and solve. So y equals negative 13 and 11. So we need to find all points that have an x coordinate that has a distance of 13 from this one point. So this is 3, right? Because that's my x coordinate. 3, negative 13. And 3 and 11. Okay, example 4. A Ford Focus and a Dodge pickup truck leave an intersection at the same time. The Focus heads east at an average speed of 60 miles per hour, while the Dodge truck heads south at an average of 45 miles per hour. Find an expression of their distance apart d in miles at the end of t hours. Okay, so here is my roads. This is north, east, south, and you guessed it, west. All right. With this, I need to know my formula for distance, which is rate times time. These right here are telling me my rate. Okay, that's 60 miles per hour. And then we have 45 miles per hour. Okay, so my Ford Focus heads east right here. I don't know where it is. It's going to be somewhere on this east coordinate. And it's going to be going 60 t. Okay, because that's going to be my distance. Is going to be my rate of 60 miles per hour times time. Well, I don't know what the time is. We're wanting to find the expression at the end of t hours. So it is 60 t. Now, if I'm writing this as an ordered pair, this is moving along my x, but it's going to be 0 along my y. So this is 60t, comma 0. 0 because it's moving up or down 0, but it's going to be going positive 60 times whatever time we're going. While the Dodge truck heads south at an average of 45 miles per hour. So this time my x is 0. And now we have negative 45t. Negative because it's going down. 45 for my miles per hour. And again, it's for at the end of t hours. So we don't know what the time is. So this is, it's sliding. It's on a piece of paper, so I can't do it, but it's sliding depending on what that time is. And so what we are trying to find is an expression to represent this distance between them at whatever time has been spent. So I'm going to write my formula. That's always a great spot to start. Okay. It doesn't matter what we call point 1 and point 2, but I'm going to call this x1, y1, so x2, y2 here. And now plug in your information. My x2 is 0. minus x1, which is 60 t, y2, which is negative 45 t, minus y1 of 0. Okay, let's simplify this sum. 0 minus negative 60t is negative 60t squared. Negative 45t minus nothing is a negative 45t. And then we'll square it. So negative 60 squared is 3,600. T squared is t squared. Plus negative 45 squared is 2,025. And then t squared is t squared. They are like terms, so we will combine to get 5625 t squared. And then this is a perfect square root. If you do the square root of 5625, you get 75. And the square root of t squared is t. And so it wants us to find an equation, or sorry, find an expression, not an equation. So here's my expression. This is my expression for the distance d in miles at the end of time t. So after 1 hour, they are 75 miles apart. After 2 hours, they're 150 miles apart. After 4 hours, they're 300 miles apart. You get the drift.